Entropy: why the universe tends toward chaos. Entropy is one of the most fascinating and misunderstood ideas in science. At its simplest, entropy is a measure of disorder, randomness, or how spread out energy is in a system. It comes from the second law of thermodynamics, which states that in an isolated system, entropy always tends to increase over time. In simple words, the universe naturally moves from order to disorder, from structure to chaos. This is not because things are lazy or bad, but because this is the most probable and natural way energy behaves. To understand entropy, imagine a neat room. When you clean it, everything is organized, books on shelves, clothes folded, items in their places. But if you leave the room alone for days, it slowly becomes messy. Clothes end up on chairs, dust gathers, objects scatter. The messy state is more likely than the neat one because there are countless ways for things to be disordered, but only a few ways for them to be perfectly ordered. Entropy increases not because someone is trying to make a mess, but because disorder has more possible arrangements. The same principle applies to the universe. When the universe began with the Big Bang, it was in a very hot, dense, and low entropy state. Energy was concentrated and structured. As the universe expanded, energy spread out. Stars formed, burned their fuel, and released energy into space. Over billions of years, this energy became more evenly distributed. Every time a star shines, a fire burns, or a machine runs, usable energy turns into less useful energy, usually as heat. This spreading of energy is entropy increasing. Entropy also explains why time seems to move in only one direction. We remember the past, not the future. A glass can fall and shatter, but it never spontaneously reassembles itself. This arrow of time exists because entropy increases forward in time. A broken glass has far more disordered arrangements than an intact one, so nature strongly favors the broken state. Reversing entropy would require an extremely unlikely rearrangement of countless particles all at once. Living systems may seem to contradict entropy because life creates order. Our bodies are highly organized, and living cells build complex structures. However, life does not break the laws of entropy. Living organisms maintain internal order by increasing entropy in their surroundings. For example, when you eat food, your body uses that energy to build and repair cells, but it also releases heat and waste. The total entropy of the system, your body plus the environment, still increases. Life is a local pocket of order powered by a larger increase in disorder elsewhere. On a cosmic scale, entropy shapes the ultimate fate of the universe. As stars run out of fuel and galaxies drift apart, the universe moves toward a state of maximum entropy, often called heat death. In this distant future, energy will be evenly spread out, temperatures will be nearly uniform, and no useful work will be possible. There will be no stars, no life as we know it, and no complex processes, just a cold, dark, and quiet universe. This is not a sudden end, but a slow fading driven entirely by entropy. Entropy is not evil, negative, or destructive by intention. It is simply a statistical rule that describes what is most likely to happen when many particles interact. It explains why machines wear out, why memories fade, why buildings decay, and why constant effort is needed to maintain order. Everything that appears stable is actually being actively maintained against the natural push toward disorder. Understanding entropy gives us a deeper appreciation of the present moment. Order, structure, and life are precious because they are temporary. Every organized system exists only by constantly using energy. In this way, entropy reminds us that change is inevitable, time moves forward, and nothing stays the same forever. Yet within this march toward chaos, the universe still allows moments of beauty, complexity, and meaning. If you found this explanation helpful and interesting, like the video, share it with curious minds, and subscribe for more simple science that explains the universe in an easy and engaging way.